Graphed here is a piecewise defined function. It has three different formulas that it follows for different parts of the domain. And we want to use the formulas in the graph to determine the values of A through G here. So when we're asked to find a particular output, it could be a good idea to identify the input first. So the inputs for this graph are going to be the x values and the outputs will be y values. For the first letter here, f of 0, notice that the input is x equals 0. So we want to go to the x-axis and just start off right here at x equals 0 and try to figure out what the function's value is at that time. Now, since this parabola touches the origin, the coordinates of that point are 0, 0. With that in mind, the output of the function here is going to also be 0. So that's our answer for A. F of 0 is 0. Now we can also determine this not just from the graph, but from the formulas as well. The input is x equals 0, so we have to look at the different parts of the domain and see which interval that fits into here. So when x is 0, it is not greater than 2. It is not between 1 and 2. It's less than or equal to 1. So we actually want to use this top formula when evaluating f of 0. And we can just plug a 0 into the formula x squared to reveal that the output of the function is 0. Let's try f of 0.99. Now 0.99 is technically less than 1. So we'd again want to use that formula, and all we have to do is just take our x squared formula and plug the input into it and see what we get as a result. I get 0.9801 for that. So when we use an input of 1 though, we're going to be on the boundary here between the x squared formula and the formula of 3. However, 1 should be included in the x squared portion because it is less than or equal to 1. So what we'd want to do is plug into the x squared formula to determine that f of 1 is actually 1. We can also see that right on the graph itself. There's this point here which has the coordinates 1, 1. And the solid dot means that it is a point that's defined as part of the graph. Alright, so that's what we'd want to put in as our output. Up here we have an open dot, but that is not defined, so we wouldn't want to use 3 as the answer to letter C. For f of 1.01, we are now not in this part of the domain anymore. We are going to be in this section. So we would now want to use the formula of 3 as our output. And 3 doesn't even depend on x. We don't even have to plug 1.01 in because there's nowhere to plug it in. So the answer is just going to be 3 for that. We can also see that the graph does hold values of 3 for anywhere where x is between 1 and 2. Here we're looking for f of 1.9. So 1.9 is between 1 and 2 as well. So we're going to still be holding that constant value of 3 at that x value. Now what happens when our x becomes a 2? Let's see, we're on the boundary between the horizontal segment and the slanted segment. However, x equals 2 is part of the horizontal section. It's part of the f of x equals 3 formula. So we still want to put 3 there. We can even see that that point is defined on the graph right here at 2, 3. So plugging in an input of 2 results in an output of 3 according to the graph. When we go to an input of 2.1, we are now at an x that's greater than 2. So we would want to follow the third formula. We'll be somewhere over here, and we just want to plug in to the formula f of x equals x. So our answer is going to be 2.1 for that.